Think like Tesla.
Think Like Tesla, Micah here, in the middle of the name badge project. Now, while we're waiting for our printed circuit boards to arrive, which should be very soon, let's take a step back and look at what the code has to do. So we've got 4 of these guys. Each one has 2 character displays in it, and they're connected like this. So character 1 and character 2, one of the 2 at a time will be connected to the positive supply rail through a switching transistor, and then we control which segments are illuminated by connecting the cathodes here to ground. So that would be a logic 0. So I've put together a worksheet to help me start figuring out what the fonts will look like. You can see that here. The lettering is just A through G around the outside edge, starting on the top left. And then the center also circles around, starting at the top left in a clockwise manner. They skip several letters to avoid confusion, like O could be confused with 0, and so forth. I'm going to make all this stuff available when I open source the project at the end here. But here's a worksheet. This is, of course, a name badge project, so the main thing I'm trying to put on here is my name. So these are what the bit codes look like for all these different letters that I'm going to need to display. In the end, I'm going to want to do a lot more than that. But that's a start. Okay, so back in the schematic here. Now you notice there's 3 lines here: data, latch, and clock. And then the even and odd enable. So here's the VCC. Here's the positive supply rail coming in through these transistors. One and only one of these at a time should be brought high. The other one should be kept low. So one of these transistors will be on and one will be off. And then recall what we said about the shift registers on these 3 lines here. So there's 8 shift registers. Each one is 8 bits. There's 8 all daisy chained together. That's a 64-bit channel. So we have to supply all 64 bits in sequence on this data line. As we're supplying the correct 1 or 0 value on the data line, we have to pulse the clock from low to high. That accepts that data into the shift register. And then once everything is in place, then we pulse the latch pin from low to high. That takes that value from the shift registers and presents it on the outputs. So we'll have to do that repeatedly at high rate of speed to show even, odd, multiplexing back and forth quickly. Pretty simple, huh? Now the only thing that might be different here is these are spec'd for 1K5. These resistors, each LED has its own resistor, so they'll all have a uniform brightness, no matter what else might be lit up around them. If we end up going with a 3.3 volt system, this might have to be a smaller value resistor. We'll come back to that. Alright, so I started sketching out some of this code in Arduino. I have this cute little device here, an Arduino, an Adafruit Feather M0. This is a 48 megahertz clock, 32-bit CPU. It's got like 256K of RAM or flash memory built in. Now you notice I'm still working on some of the details here of the code, so don't take anything here as gospel just yet. We're going to define all the pins up here, set them as outputs, and then basically here's the logic that we just talked about. And this is probably not correct yet. It's still a work in progress. Once we get the circuit boards in, we'll build the circuit up and we'll actually try it out for the first time. That should be exciting. So we're passing in an array of character data. Here's what some of the data looks like: uppercase M, lowercase I. We're passing in the array, and then we have to say how many things are in the array. In this case, the even or odd are always going to be 4 digits, so that's what num will be. So we start from the last thing we send in, and we work backwards towards the front, and we start from the least significant bit. So we start off from those U segments, right? We start off with the U segment and work backwards, filling in the last digit, and then backwards around the outer ring, but starting back to A, and then the next digit previous to that, back. So hopefully I got this logic right. So we feed the data one at a time onto the data pin, and then we pulse the clock pin. This is a delay of 1 millisecond, which is way, way too long. It's going to slow this thing down like crazy. I will look up in the data sheet what this needs to be and update that code in a second here. Then once all the bits are in place, we pulse the latch line from low to high, like that. And then quickly as possible, we swap even and odd. So we either take high-low or low-high, depending on which one we're writing. And we write that to the pins. That should be it. We just run this in rapid-fire sequence, and we have a display lighting up. Now I do want to set aside 8 16-bit values for a display buffer. So whatever I want to have on the display at that moment is just in the buffer. Then we'll have some timer routines that just go on and do the multiplexing at a good clip. Then if we want to change what's on the display, we just change what's in the display buffer. So that will decouple those two pieces of code. But yeah, this is looking good. Hopefully, once we get our hands on the hardware, things will be looking good. So stay tuned for details, guys. This is almost working. I can feel it. All right, soon. Later, guys.